Tuberculosis is an extraordinarily widespread disease. Over a quarter of the world's population harbors dormant tuberculosis, and every year, millions of people are afflicted by the active form of the disease. TB is very challenging to diagnose and treat, especially multi-drug resistant forms of it. Here at Central Michigan University, my group creates new chemistry-driven tools to study and target the molecules within the bacterial cell envelope. This envelope is a tough barrier that provides protection to the bacterium. But because it consists of unique molecules that are not present in humans, it is also an Achilles heel, which chemists can exploit to create better ways to study, detect, and treat infections. Students working in our lab have developed simple and efficient methods to produce these compounds and ensure that they're accessible to other researchers. We emphasize the use of environmentally friendly reactions in these methods. Students have developed new tools for characterizing cell envelope proteins, which are possible targets for future drug development, new reagents to rapidly and specifically detect these bacteria, and new inhibitors that stop construction of the cell envelope and prevent bacterial growth. All of the tools we develop are tested in our high containment biosafety level 3 facility so that their applicability to the TB pathogen can be explored. At every stage of these research projects, from conception to execution, understanding and applying chemistry is central.